In this video, I'm going to show you what happens in ionic bonding, and we're just looking at the molecules here. Actually, we're looking at the ions here, but that's another story. And now, the key thing is, sodium is in group 1. It's got 1 outer shell electron, and you will know from the periodic table that chlorine has got 7 electrons in its outer shell. Its configuration is 287. Now, the thing is, both of them would really like to have a full outer shell. They don't really like just having 1 in its outer shell, and chlorine doesn't really like having a gap there. It's not too happy with those at all. Now, so what happens is that electron moves across, and it's gone from sodium and it's gone across over there onto the chlorine, which is given sodium an outer shell, an electronic configuration of 2,8 and chlorine 2,8,8. And they both got full outer shells. They are much happier. Now you see this one here has been drawn as a dot. That's just to show that it has come from the sodium. These are all drawn as dots. These are all drawn as crosses, but they are identical. So it just shows where they come from. Now then, because sodium has lost an electron, it's now slightly positive. It's got one too few electrons, and it's got more protons in its nucleus than it's got electrons. It's got an electronic configuration of 2,8, and it's positively charged. Chlorine is the opposite. It's got 1 electron extra, and therefore it's slightly negative. These charged particles are called ions. We draw them with brackets around them. Now these ions are all attracted together into a giant lattice. Millions and billions and trillions of them. Now, nobody would ever want to draw something that looks like that. So it's generally drawn something like this. You've got a simple version, which is just showing them on a flat plane, but they're not really like that. They are 3-dimensional. If I get rid of that, please. Then we've got this one here. This is another way of showing it in a 3-dimensional way, and this is another 3-dimensional way of showing it. They're just different ways of showing exactly the same thing, that you've got lots and lots of positive and negative ions all joined together. Now then, let's do a few examples. Here's the sodium chloride that we had in the first place. We've got sodium and chlorine. Now then, first thing is we must draw the electrons on both atoms, and they are atoms at this point. There we are. You can get that information from the periodic table. Sodium is 281, chlorine is 287. Now, remember, the sodium has got dots to represent electrons, the chlorine has got crosses to represent the electrons, but they're just the same. Anyway, that single outer shell electron moves across to the other side. There we are. I've put an arrow, just showing it's going across. So let's draw the arrangement of the ions. They're like that. And I'll put their brackets on and write the configurations and show the charges, and that's the way it's looking. This is now a sodium ion with 1 less electron joined onto and stuck together the chlorine ion with 1 extra electron. Now then, let's have a look at lithium chloride. We're going to go through the same stages, just through the same stages now. I don't know why that plus sign's gone mad. However, lithium is 2,1, chlorine is 2,87. The electron moves, it goes across, it goes from one to the other. Remember, it's a dot going over to where the crosses are, but they're all the same as each other. That leaves lithium with just 2, and it leaves chlorine with an extra 1. They've both got full outer shells, they're both happy, and there go the square brackets and the charges. That is the way that lithium chloride would look. Here we are, potassium fluoride. It's the same idea. We can look up the information from the periodic table. Potassium has 2,881. Fluorine is 2,87. Show the things, show where they're going. And I'm looking at those diagrams, I'm thinking they have not been finished. I wished I'd finished them. I think maybe at this point I need to be leaving them right now because those diagrams aren't quite right. But you get the picture.